So this is our last chapter. It's super, super short. It's hard if you guys don't know how to factor, right? The ending steps for these solving trig equations are all the same. It's just a matter of how you solve. Like when we think about when we go to solve for x, right? When there's not an exponent, it's pretty easy. You just get all the x's to one side, numbers to the other. But when we start getting like x squareds in there, we might have to factor using double bubble, or maybe using the quadratic formula. So you guys have like more than one way to find x in a regular equation. Some are easy, some are kind of tough. Same idea when we're doing first degree trig equations. Does anybody know what a first degree means? It means that the highest exponent is 1, right? So this means just x should be our like highest thing we're working with.
So it's not x to the first.
Right, it's not like x squared or x cubed, so it's going to be x to the first. Okay. So if you guys can do the top little star problem, I know this seems probably very easy for you. We can get to the hard part of what we need to do. Okay, how would you guys go about solving for x? -3, good job. So we have 4x equals 2, and then you would divide by 4. So x would just be 1/2. Now, can you guys all do that? Yeah. So if you guys can do this, we can solve the trig equations. They just look tougher. And one thing is, if you have, like here, we just have only sign. What we could do is we could think of the trig equation, or the trig function, like x. So if you guys change this, it would be like this. 4x plus 3 equals 5. How would we solve this? Yeah, -3. We have 4x equals 2 divided by 4. And then x would still be 1/2. But what was x in the beginning though? It was sine theta. Now if this is easier for you guys to visually see by making it like an x and just solving, go for it. If you're someone who can, yeah, exactly. If you're someone who can do it the way it looks and just get everything away from the sign, you know, that's kind of where we want to be headed, right? But for now, it's easier for you guys to just like rewrite as an equation. That's okay, right? So just make sure we have to remember that really this is sine theta equals 1/2. Okay? Once you guys get the sine theta or like the x alone, our job is to find theta, right? Solve for theta, or find your missing angles. We want to notice that we can be equal to 0 or equal to 360. We don't. No, I will check. Okay, that's fine. I don't have notes. Okay. So you gotta actually write it. Okay. Sorry. Are you gonna be here tomorrow? Can I get you tomorrow? Okay. So I just gotta put it. Okay. All right. So when you guys are missing your degree, here's your next step. What key do you have to hit? Second function key. Good job. So make sure that you guys are in the correct mode, okay? Make sure we need to be in degree mode. So watch out, degrees highlighted. So we're going to do second sine and put in your 1/2. So you get 30. Great. Well, the sine of 30 is 1/2. Oh. Right. So we have theta 30. Now, the tough part, people always forget to do this last step, okay? We want to make sure all this stuff kind of gets rolled into one problem. We have multiple places where the sign is a positive value, right? Because 1/2 is positive. So we have the A and the S quadrant where sign is positive. In the A quadrant, we got 30 degrees. But what would this angle be a possibility for in the S quadrant? 150. Good job. Do you guys remember that going back? So if we took 180 minus 30, we would get 150. So these two are the possibilities that theta could actually be in here. Theta could be 30, or theta could also be 150 degrees. Both of those values would give me a 1/2. If you're not sure, we can check. If you guys try to do sine of 30, let's see, I should get 1/2. Same thing with the sine of 150. I get 1/2. Those both are possibilities. So it's a lot of steps you guys have to remember to check for these. The ending part is going to be the same for all 3 lessons. It's just the solving part that's going to change, like how we have to solve. Do you guys remember checking quadrants? It shows up like everywhere. It's not like one of those questions where you say this is always a part one. They've done these on like part one with multiple choice, part twos, part threes, and I've even seen, you'll see on Wednesday when we do the real tough stuff, it's like they can make it a 6-pointer. So they're like, you'll get one of these, I just don't know where it'll be. Kind of idea.
Can you join the region 4?
Oh, I wish I could smuggle it out for you guys.
I can join that.
No luck. I don't know. I don't think you can teach anyone. We've got to. They don't really want to care. All right. So here we go. We want to solve for. I'm going to say theta. I shouldn't have tan in there anymore. So here, same thing. If you guys are having issues with like looking at the problem with the trig functions in there, if we want to, I mean, you don't have to do this. We can make it look like instead of the tan theta, we could put an exponent. Wherever you guys see that. So really, this is just like solving on the right side here. I'm hoping we can all solve these type of equations. The equation part's not that hard. Right, so go ahead and get your x loan or get the tan theta loan, however you guys want to work. Yeah, today's not too bad, but the hardest part's the ending, just making sure you guys remember all the things you have to check. All right, did you guys get -3/2 for either your tan theta or your x, whatever you guys are dealing with? Okay, perfect. So once you're here, same exact procedure, right? Our job is to find theta, so we're going to use our second function key. So second tan is our -3/2. All right. So let's round from there. We'll do yours whole numbers. I didn't say anything about it. So wherever they tell you to round, do it. Let's round yours whole and make it easy. So we got -56. Okay, great. All right. So our theta is equal to -56 degrees. One thing we want to be careful of is making sure you guys are following what they give you. Right? In the beginning, right, we want everything from 0 to 360 degree wise. And notice your little underneath it saying including. So when we look at our angle that we just got, it's -56 between 0 and 360. Not between. Yeah, good job, Matt. Exactly right. So we can't, this isn't going to be our final answer, right? We've got a lot of work to do with this. In your quadrant, if you went back 56 degrees, there's 360, and if we went down 56, what would this angle be? What do you guys think? 360 minus 304?
Yeah.
Great, good job. Right. Now, is 304 between 0 and 360?
Yeah.
Yeah, so this is looking good. Now, theta could be 304, because that's between my interval that I need. We also have to check out if tangent's positive or negative. Look at your value here. What do we think, positive or negative? Negative, right. So A, S, T, D. Right. Good, Aaron, awesome. Tangent is also going to be negative in the S quadrant. So we have to be in these two quadrants. We already have our 304, which is great. How are we going to get into the second quadrant, though? What would you have to use? And here's your 180. What's the reference angle? 56. Nice, Carly. Didn't you guys have to use 56 in here? Right. So if you want to get into the S quadrant, we have to use 56. What would we do with 180 and 56? Subtract it. Good. You already got it? What'd you get? 124. Good job. Okay. So we have two possibilities here. We have theta equals 304 and 124. And we don't want to use that -56 because it's not between the 0 and 360, which is what we wanted. So 56 was, that -56 was important because we yeah, it's the reference angle, but we're not going to take that as our final answer because it's not in the interval. So the ending part is where the tricky stuff happens. You guys have to remember to check your quadrants, to figure out your other values. Yeah,
Will they always give you an interval?
yeah. Yep, they'll always give you guys an interval. Right. A little bit tougher here. So find theta in this one. Notice, can you guys include 360 here? No, okay. So sometimes we try to do that to trick you up a little bit. All right, well, first thing, we have only first degree. We got secant this time. It's a little tricky. Right? If you guys would rather make it become an S, that's totally okay. Right? So this would be how the other way we would solve it out. Is the solving part going okay for you guys? Is the actual question okay? Okay, great. So, secant theta equals 2. That's really what we were dealing with. Now, do we have a second secant button?
There's just be 1/2.
What would you use though? Close. Cosine. Yeah.
Oh.
Right. You're exactly. Good job, Frida. All right. We don't have that second sign. There's our second secant button. So what we have to do is use its reciprocal function. Right. Secant, we can use cosine, but what would you have to do with the fraction? Flip it. Yep. Good job. So we have to use this part. Now we can use our calculators for it. Pretty tricky.
Why would you have to flip the second?
Like this part right here?
Yeah.
Because like way back when we first learned about reciprocal functions, anytime I asked you guys like, well, actually this might make sense. All right, secant is really 1 over the cosine. So if you guys did 1 over the cosine, I think this will work too. If you did 1 over, oh yeah. Actually, no, that's not enough. I'm trying to think of an easy way. The easiest way is just actually flipping the fraction, so then you don't have to do 1 over it. Let me give you an example. Can I use like different numbers?
Yeah.
Okay. So what about if I had like the cosine of theta equals like 4/5? Right. And you wanted to find the secant of theta, which you'd have to do is 1 over the cosine value. So this would be like saying 1 over 4/5. Now, if you have a fraction over another fraction, it's copy, change, flip, right? So if you copy, change, flip this, then it becomes 5/4. All right. So instead of doing that like 1 divided by, you just flip it.
Okay.
Sorry, does that help?
Yeah, no.
So yeah, in order to do this, we have to flip the fraction. Right. Okay, so here's the tough part. We've got a lot of things to think of. Your goal is to find x. What quadrant should you guys be looking at if it's a positive 1/2?
The 1 and 4.
1 and 4. Good job. We got A, we got S, G, and C. So 1 and 4. Good. We want to be in these 2 quadrants. That's where cosine is positive. So let's find x. Right. These are second function Z. The second cos. 60. Good job. Great. Okay, so we're going to do that right away. So we have our 60 degrees. Is 60 degrees going to be in our interval? Yeah, it's between 0 and 60. All right, so that theta equals 60. That's good. Now to get into the other quadrant, to go down, here's your 360. What would we do with it? Good job. Nice work. What would you get? 300. Super. Is 300 in our interval? So those are going to be your 2 answers.
There's only ever 2 of them.
Well, for right now. When we start dealing with like second degree, we're going to have more. The biggest part is that you guys get the bottom part, because this is going to be what's going on for the next like 3 days, right? So the same process once you get your like trig function by itself. Let's try the next one. What do you guys think you would do here? Distribute. Good job. Then if you want to make it like 3 bubble x minus 1 equals negative 4, and think about it that way to solve, that's okay. Let's use the same interval here. Let's put more intervals. Did you guys get negative 1/3?
Yeah.
Okay, good. You just remember what you're dealing with. I'm dealing with the sine. So sine theta equals negative 1/3. Okay. All right. What quadrants should we determine in? Is it positive or negative? Negative. Good. So I heard 4 and 3. Good job. Great. Sine is going to be negative in the 4th quadrant and the 3rd quadrant. So let's figure out what theta could be.
What are we round to?
Let's go to this 10th here. How's that sound? Let's do this 10th one. The second sine, we'll put our negative 1/3 in. Negative 19.5. How's everybody with the calculator stuff? Are you able to put this in okay? And theta equals negative 19.5. Now negative 19.5 would be going down. 19.5. There's your 360. Can we take negative 19.5 as an answer? No, it's not in the interval. So we have to think about what would that really be? What is it? Carly's saying 340.5?
Yeah.
Good.
199.
Okay, good job. Now 340.5, that's looking pretty good because that's in our interval. 340.5. Frida, what did you do to get into your 3rd quadrant?
I added 19.5 to 1.
Good job. 19.5. And what did you get then?
199.
190.
Oh, 9.
25. Good job. Then Karen?
No.
Oh, sorry, stretching.
Wait, I say after that is it.
Nothing.
I say after that.
Yeah. What else? So if you think about like in your, on your unit circle, it goes like 0, 360, 90, 180, 270, right? So this 19.5 is our reference angle. It's kind of like how we're moving into different quadrants. So if you wanted to get into the 3rd quadrant where this is, bless you, you have to take 180 and add 19.5 because you're going in a positive direction, so you're adding that direction. And then this would be your other option, right? You don't want to take that negative 19 because it does not fall into the 0 through 60. Right? Just make sure you guys always check on what's included in the interval. It's just 2 answers here. How are we doing so far? I know this stuff is kind of like, I think this is like the worst chapter. Is this like terrible, good, bad? Easier than the last one? Alright, well, that's good.
Yeah, the last one didn't have any numbers.
Oh, alright, well maybe you guys will like this then. It's just a lot of steps at the end. So just making sure you guys always remembering quadrants, like are you positive, negative, all that stuff. Alright, here's your last one. This would be as hard as you would get with a 1st degree. If you see a 1st degree, one thing I can tell you, like this specific topic would only be a multiple choice or a part 2 question, right, with a 1st degree. But when you start getting into like 2nd degrees, usually the 2nd degrees are like the part 3s, and if they gave you like one of the brutal ones we're going to do Wednesday with substitution, that could be a 6-pointer. So this whole chapter kind of ranges, and I mean, doesn't mean you're going to see one of those. So. We'll try to be ready for everything. Okay. All right. So let's see. What find the exact value of theta in our interval? Now look at this part. This is kind of weird. We haven't seen this yet. What does that mean? Radian mode. Yes. Good job. So we need to make sure that we're putting things in radians if our interval is given in radians.
So let's start with actually like figuring this out. We'll change this into an x. 2x plus 3 radical 2 equals 3 radical 2. Okay. All right. So are we minusing 3 radical 2? Can we actually do the subtraction? Are those okay?
Sure.
Yeah, because we have the same number underneath the radical. So this is going to be a negative 1 radical 2. Negative radical 2 works. Divided by 2. That's right. Alright. So x equals a negative radical 2 over 2. Okay. And remember, x was really cosine theta equals negative radical 2 over 2. Alright. Yeah, something to do with 45. You guys be careful though, because it's negative. Nope, we're just going to do the conversion after. So, Frida, look what you were thinking there, like right before you even did anything, you knew it had something to do with the 45. Well, watch out with your quadrants because it was a negative. So let's type in second cos. We have negative radical 2. Please watch out. You guys are doing with the radicals, tab it over, right? Make sure you end it at the right spot. Let's see what we got. You guys get 135?
I thought I just switched to radians or whatever.
You switched it?
Yeah.
When we give it to for the decimal, give it to the decimal there. Go into keep it degree, and we'll do the conversion because your conversion is going to be messed up this morning. You're welcome. Did you guys have 135, right? Alright, let's pick our quadrant that we should be in. Right? Cosine here is negative. Where do we have to go? Second and third. Good job. So these are the two we want to go into. All right, 135 degrees. 70. Right. 135 is already over here. And so 135 is looking good. Now, what else? How can we get into this T quadrant though? What do we have to find? Yeah, Frida, good. What is the difference in here? What is the reference angle? 45, yep. And that's where the 45 comes in. Okay. Now, is 45 one of our options? Is that one of our answers? Okay. Careful, you're not using 45 is an answer because 45 would be over here. We don't want things in the first quadrant. Yeah, good, Carly. So you're just going to take your 45 and add it to 180 now to get the other degree of 225. Good job. Okay. So right now we have two answers. We have 135 and 225. Good. Now, be careful though, because a lot of times they're going to trick you guys like this. Is this in radian form? No. We're only going to switch it into radians because of how are the intervals given to us. So we have a little bit more work, and they like to do this to kind of. Remember I told you guys they want to put as much stuff together as possible. So this is a way that they could test you on this and converting into radian form. We can kind of tell like two questions in one. So watch out for this part. What do we multiply to go into radians? Good. Pi over 180. Nice, Stevie. Good job. Okay. So we have to convert both of these into radians. Okay. Now when you guys did your converting, top, bottom, bottom. So it was like saying 135 pi over 180, but you always saw the fraction in reduced form. So we want to reduce the 135 and the 180 by just using division. 135 divided by 180. Right, use your math fraction key. So this would be like 3 pi over 4 into radians. 3 pi over 4. So that's going to be one of them. Why don't you guys try the 225? Let me know what you have. Yeah, no, that's it. Yep, and use that fraction. Perfect. Anybody else get 5 pi over 4? Good. Right, and that would be the 2 answers that you guys use in radians. So it is, I know it's a little bit tricky. Your homework tonight is in the textbook. Your textbook's actually really good this chapter. Some chapters it stinks, we don't use it, but sometimes it's good. So, what I have is on page 525, 21 through 24.